The U.S. Air Force's new C-5 Galaxy is the largest plane ever created. Designed to handle massive loads, this enormous aircraft possesses the unique abilities to operate from short, narrow runways and even rough, unpaved surfaces. Equipped to carry both heavy military equipment and large numbers of troops, the C-5 Galaxy has set a new standard in airlift capability, showcasing the power and versatility of modern military transport. What design makes this large aircraft stand out amongst others? What are the capabilities of the C-5, the most advanced transport aircraft in history? Join us as we explore the complexity of the U.S. new C-5 Galaxy, the largest plane ever created. This technological marvel was built to be rugged, equipped with the ability to carry very large and oversized items, including all types of air-certified cargo. This advanced plane shares many features with the smaller Lockheed C-141 Starlifter and the later Boeing C-17 Globemaster III. There is no doubt that the C-5 is one of the largest military planes in the world. However, great things never come easy. The development of this extremely large and advanced military transport plane was quite challenging, with high costs causing financial problems for Lockheed. Soon after it began service, cracks were found in the wings of many planes, limiting their use until repairs were made. The C-5M Super Galaxy is an improved version with new engines and updated electronics, designed to last until at least 2040. The military plane has been operated by the United States Air Force since 1965. It has supported U.S. military operations in major conflicts like Vietnam, Iraq, Yugoslavia, and Afghanistan, and has helped allies such as Israel during the Yom Kippur War and in the Gulf War. It has also delivered humanitarian aid, provided disaster relief, and supported the U.S. space program. In 1965, several aircraft companies started working on designs for heavy jet transports to replace the Douglas C-133 Cargo Master and work alongside the Lockheed C-141 Starlifters. The U.S. Army wanted a transport plane with a larger cargo bay than the C-141, which was too small for their large equipment. This led to the CX-4 requirement in July 1962, with Lockheed, Boeing, Convair, and Douglas suggesting 6-engine designs. By late 1963, the CX-4 was replaced by the CX-HLC requirement, calling for a 4-engine airlifter with a gross weight of 550,000 pounds, a maximum payload of 180,000 pounds, and a speed of Mach 0.75. The cargo compartment had to be 17.2 feet wide, 13.3 feet high, and 100 feet long, with doors at both ends. USAF studies indicated that high bypass turbofan engines were needed for the necessary thrust and fuel efficiency. The criteria were finalized, and an official request for proposal for the heavy logistics system was issued in April 1964. By May 1964, aircraft proposals came from Boeing, Douglas, General Dynamics, Lockheed, and Martin Marietta, with engine proposals from General Electric, Curtiss-Wright, and Pratt & Whitney. After narrowing down the choices, Boeing, Douglas, and Lockheed received 1-year study contracts for the airframe, and General Electric and Pratt & Whitney for the engines. All 3 designs shared several features, such as placing the cockpit above the cargo area to allow loading through a nose door. Boeing and Douglas put the cockpit in a pod on top of the fuselage, while Lockheed extended the cockpit along the fuselage, giving it an egg-shaped cross-section. Each design had swept wings and front and rear cargo. The Air Force thought Boeing's design was better than Lockheed's, but Lockheed's bid was the cheapest overall. Lockheed was chosen as the winner in September 1965 and received the contract in December 1965. General Electric's TF-39 engine, which was selected in August 1965 to power the new transport plane, was revolutionary because it had a bypass ratio of 8-to-1 compared to the less than 2-to-1 ratio of previous engines. This new ratio provided more thrust and better fuel efficiency. Although Boeing lost the military contract, they went on to develop the successful 747 civilian airliner, with over 1,500 planes built by the time production ended in 2022 after 54 years. The first C-5A Galaxy came out of the factory in Marietta, Georgia, on March 2, 1968. On June 30, 1968, it made its first flight, piloted by Leo Sullivan, using the call sign 8303 Heavy. During testing, the plane had more air resistance than expected. The lift was better than expected with the flaps at 40 degrees, but worse than expected with the flaps at 25 degrees and with the flaps retracted. The aircraft's weight was a big problem during its design and development. When it first flew, the weight was under the guaranteed limit, but by the time the ninth plane was delivered, it was over the limit. In July 1969, a test showed that the wing broke at 128% of the maximum load, which was below the required 150%. Even after making changes, another test in July 1970 showed it failed at 125%. A new system was added to help with this, but the maximum payload had to be reduced from 220,000 to 190,000 pounds. There was also a 90% chance that no more than 10% of the 79 planes would last 19,000 flight hours without the wings cracking. The C-5A had caused overruns and technical issues that led to a congressional investigation in 1968 and 1969. It was the first program to exceed its budget by $1 billion, which is equivalent to $8.3 billion today. Because of these problems, the Department of Defense stopped using the total package procurement method. In 1969, Henry Durham, who worked for Lockheed, raised concerns about the production process. He was then transferred, mistreated, and eventually resigned. Some of his claims were later confirmed by the Government Accountability Office, and he received an award from the American Ethical Union. Another person who pushed it for accountability, Ernest Fitzgerald, faced similar resistance. After testing finished in December 1969, the first C-5A was sent to the Transitional Training Unit at Altus Air Force Base, Oklahoma. In June 1970, Lockheed delivered the first operational C-5A to the 437th Airlift Wing at Charleston Air Force Base, South Carolina. Due to higher-than-expected development costs, people called for the government to help cover Lockheed's substantial losses in 1970. In 1971, production almost stopped because Lockheed faced financial troubles, partly due to the C-5 Galaxy's development and a civilian jet, the Lockheed L-1011. The U.S. government provided loans to keep Lockheed in business. In the early 1970s, NASA thought about using the C-5 to transport the space shuttle to Kennedy Space Center, but chose the Boeing 747 instead because of its low-wing design. The Soviet Union, on the other hand, used the high-winged An-225 to transport their shuttles, which was based on the An-124, similar to the C-5. During testing, cracks were found in the wings of several C-5As, so the fleet was limited to 80% of the maximum load. To reduce the stress on the wings, load alleviation systems were added. By 1980, payloads were limited to as low as 50,000 pounds for general cargo during peacetime. A $1.5 billion program called HMOD started in 1976 to replace the wings on 76 C-5As, to restore their full payload capacity and extend their service life. The new wings were designed and tested, and the C-5As received them between 1980 and 1987. Restarted production and development started in 1974. Iran, which had good relations with the United States, offered $160 million to restart C-5 production so they could buy the aircraft for their Air Force. This was similar to how they acquired F-14 Tomcat fighters. However, Iran did not end up ordering any C-5s, and the idea was completely stopped by the Iranian Revolution in 1907, when the Imperial State of Iran was replaced by the Islamic State of Iran. As part of President Ronald Reagan's military policy, funding was provided to increase the USAF's airlift capacity. Since the C-17 was still years away from completion, Congress approved funding for a new version of the C-5, the C-5B, in July 1982. The first C-5B was delivered to Altus Air Force Base in January 1986. By April 1989, the last of 50 C-5Bs was added to the 77 C-5As in the Air Force. The C-5B had all the improvements of the C-5A plus additional system modifications for better reliability and maintainability. In 1998, the Avionics Modernization Program, AMP, started upgrading the C-5's avionics with a glass cockpit, new navigation equipment, and a new autopilot system. Another modernization effort, the Reliability Enhancement and Re-engining Program, replaced the engines with newer, more powerful ones. A total of 52 C-5s are being modernized through the RERP program, which includes 49 B models, 2 C models, and 1A model. The program features over 70 changes and upgrades, including newer General Electric engines. 3 C-5s were tested with these upgrades first. Low-rate initial production began in August 2009, and full production started in May 2011. By August 2014, 22 C-5M Super Galaxies were completed. The RERP upgrades were finished on July 25, 2018, and the last modified aircraft was delivered to the Air Force on August 1, 2018. In 2014, Lockheed explored reducing drag by using plasma heating on turbulent airflow, which would save weight by cutting fuel consumption. The Air Force Research Laboratory also looked into using shape memory alloys for vortex generators that adjust based on speed. Now let's explore the designs of this military aircraft. The C-5 is a large cargo plane with a high wing and a distinctive T-shaped tail. It has 4 TF-39 turbofan engines under its wings, which are angled back 25 degrees. The C-5M version uses newer GE CF6 engines. It is similar in design to the smaller C-141 Starlifter. It has 12 internal wing tanks and can be refueled in the air. Above the long cargo area is an upper deck for flight operations, seating 80 passengers in rear-facing seats, and the loadmaster crew in forward-facing seats. The plane has doors at both the front and back for easy loading and unloading of cargo. The cargo hold of this aircraft's 1 foot longer than the entire length of the Wright brothers' first powered flight at Kitty Hawk, North Carolina. Due to its high fuel consumption and maintenance problems, the Galaxy's aircrews have nicknamed it Fred. The plane needs 8,300 feet to take off and 4,900 feet to land when it's fully loaded. It has 28 wheels on its landing gear to spread its weight on either hard or soft surfaces. The back landing gear can turn to allow tighter turns and rotates 90 degrees after takeoff before being pulled up. The landing gear can also lower the plane when it's parked, so the cargo area is at the height of a truck bed, making it easier to load and unload. It has a system that detects and records errors throughout the plane. The cargo area is 121 feet long, 13.5 feet high, and 19 feet wide, giving it a space of just over 30 cubic feet. It can hold up to 36 large pallets or a mix of pallets and vehicles. The cargo doors at the front and back open fully to make it easier to load large items. The ramps are wide enough to let 2 rows of vehicles be loaded from either end of the cargo area. The C-5 Galaxy can transport almost any kind of military equipment, including large items like the Army's armored bridge that weighs 74 tons. It can carry equipment from the U.S. to anywhere in the world and can fit up to 6 Apache helicopters or 5 Bradley fighting vehicles at once. Later on in October 2011, the 445th Airlift Wing, based at Wright-Patterson Air Force Base, replaced all remaining C-5s with C-17s. The McDonnell Douglas Boeing C-17 Globemaster III is a big military transport plane developed for the U.S. Air Force from the 1980s to the early 1990s by McDonnell Douglas. It continues the name of 2 earlier military cargo planes, the Douglas C-74 Globemaster and the Douglas C-124 Globemaster II. The C-17 was developed from the YC-15, a smaller prototype airlifter from the 1970s. It was meant to replace the Lockheed C-141 Starlifter and take on some of the Lockheed C-5 Galaxy's roles. The C-17 had swept wings, was larger, and had more powerful engines compared to the YC-15. The development faced many design problems, leading to a loss of about $1.5 billion. The first C-17 flew on September 15, 1991, about a year late. It started service with the U.S. Air Force on January 17, 1995. After Boeing merged with McDonnell Douglas in 1997, they continued to build the C-17 for nearly 20 years. The last C-17 was finished and flown on November 29, 2015. The C-17 is used for moving troops and cargo around the world, and also for medical evacuations and airdrops. It is used by the U.S. Air Force in other countries, including India, the UK, Australia, Canada, Qatar, the UAE, Kuwait, and the Heavy Airlift Wing in Europe. The C-17 was crucial in delivering supplies during the wars in Afghanistan and Iraq, and in providing aid after natural disasters like the 2010 Haiti earthquake, the 2011 Sindh floods, and the 2023 Turkey-Syria earthquake. In the 1970s, the U.S. Air Force started looking for a replacement for its Lockheed C-130 Hercules cargo plane. They held a competition called the Advanced Medium STOL Transport, where Boeing proposed the YC-14 and McDonnell Douglas proposed the YC-15. Although both planes met the requirements, the competition was canceled before a winner was chosen. In November 1979, the Air Force launched the CX program to develop a larger aircraft with a longer range for strategic airlift. Development issues and limited funds caused delays in the late 1980s. There were criticisms and questions about whether there were more cost-effective options. In April 1990, Secretary of Defense Dick Cheney cut the order from 210 to 120 aircraft. The 15 flew on September 15, 1991, at McDonnell Douglas's plant in Long Beach, California, about a year later. The first aircraft and 5 more were tested at Edwards Air Force Base, and 2 airframes were built for static and load testing. The C-17 Globemaster III faced significant challenges during its development. Initial static tests revealed that the aircraft's wing failed at 128% of its design limit load, falling short of the 150% requirement. After spending around $100 million to redesign the wing, a follow-up test in 1993 showed it met the standards when correctly loaded. Despite these setbacks, the C-17 was named Globemaster III in early 1993. Production issues and budget cuts put the program on the line, with the Department of Defense threatening to terminate the contract if problems weren't resolved after the 40th aircraft. McDonnell Douglas faced a staggering $1.5 billion loss on the project. Meanwhile, alternatives were explored, including modifying existing aircraft or restarting production lines, alongside continuing C-17 development. The C-17 Globemaster III is a strategic transport plane designed to move cargo close to combat zones. Over the years, U.S. military equipment has become larger and heavier, increasing the need for airlifting big, heavy items. The C-17 is 174 feet long, with a wingspan of 169 feet 10 inches, and uses about 8% composite materials, mainly in secondary parts and controls. Its wings are angled downwards, and this helps it attain better stability, and its T-tail design helps keep the plane balanced by raising the center of pressure higher than the center of mass. This design also reduces drag by keeping the wings away from the air disturbances created by the plane's engines. The C-17 is powered by not just one, but 4 powerful Pratt & Whitney F117 PW100 turbofan engines, which are based on the commercial PW2040 used in the Boeing 757. Each engine produces 40,400 pounds of thrust. The engines that propel this aircraft have thrust reversers that direct exhaust air upwards and forwards to minimize damage from runway debris and help the plane reverse while taxiing. These reversers can also be used in flight for extra drag during steep descents. Tests have shown that flying in the wake of another C-17 can save up to 10% in fuel, which is considered quite economical. For cargo missions, the C-17 needs a crew of 3, a pilot, a co-pilot, and a loadmaster. The cargo area is 88 feet long, 18 feet wide, and 12 feet 4 inches high. The floor has rollers for moving pallets, but can be adjusted to a flat surface for vehicles and other rolling items. Cargo is loaded through a large rear ramp that can handle heavy equipment like a 69-ton M1 Abrams tank, along with other vehicles, trucks, trailers, and palletized goods. The C-17 can carry a maximum load of about 170,900 pounds of cargo and has a maximum takeoff weight of 585,000 pounds. With 160,000 pounds of cargo and cruising at 28,000 feet, it can fly about 2,400 nautical miles on early models and up to 2,800 nautical miles on extended range models with extra fuel tanks. Its cruising speed is around 450 knots, and it can drop 102 paratroopers in their gear. Boeing states that, when empty, the C-17 can fly up to 6,230 nautical miles, which is quite exceptional. One unique feature of this plane is that it is built to use runways that are as short as 3,500 feet and as narrow as 90 feet without getting damaged. It can also land on rough, unpaved runways, though this might risk damaging the aircraft. The thrust reversers help move the plane backward and turn around on tight taxiways. The C-17 requires about 20 hours of maintenance for every flight hour and has a mission availability rate of 74%. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.